You're unbelievable. You're unbelievable.
Welcome back to another unbelievable day of physics. Today we're learning how to make a correct equation for a linear graph. In algebra, you learned that the equation of a straight line is y equals mx plus b. We're going to use this exact equation to find our formulas for a line. When we look at this equation, the y is our dependent variable and the x is the independent variable. Both of these are just the labels of the variable without any units. M and b are going to be the numbers that do show the correct units. M is the slope of the line. We find the slope by taking the rise over run. In other words, how much the graph goes up divided by how much the graph goes over. B is the y-intercept. It's where the line crosses the y-axis on our graph. Your math teacher uses the variables x and y since they rarely use real-life variables in their sample problems. We don't want to use x and y in physics because x and y don't physically represent anything. They're what we call dummy variables. Your math class is just trying to teach you how to solve for variables, but we're only going to graph things that we measure and that we want to try to determine the relationship. We want you to use the actual variables that are given in the problem for the equation, not x and y. So let's look at an example so you can see exactly how we're going to plug that in. Let's say we have this following data right here. Then the graph of this data would look something like this. We can see that this is a linear relationship. So we can find the line by using y equals mx plus b. The y stands for our dependent variable, which in this case was the distance. The x is the independent variable, which for us is time, or we'll just abbreviate it with a little t. Remember that these variables don't have the units in the equation. To find the slope of the line, we take 2 points that fit right on our best fit line. So you look at the graph and find 2 data points that are exactly on your line of best fit. So in this case, let's just take our first and our last data point. For the rise, to find the slope, which is rise over run, we find the rise, which our first data point starts at 15 and ends at 90. So the line went up 75 meters, since 90 minus 15 is 75. To find the run, we see how far over the graph went. The same first data point that we looked at before started at 5 seconds, and the last data point ended at 30 seconds. So the graph went over 25 seconds, because 30 minus 5 is 25. The slope is determined by rise divided by run, so we get 75 meters divided by 25 seconds. Remember those units, because we can't just get rid of them. So we end up with 3 meters per second. To find the intercept, we look at where the line crosses the y-axis. In this case, the line crosses right at the origin, or 0, 0. So our y-intercept is 0. Now when we plug all of these values into our y equals mx plus b equation, it becomes d equals 3 meters per second times t plus 0 meters. Now 0 really is nothing, so we can just get rid of the 0 and drop it, and we end up with just d equals 3 meters per second. Let's look at another example. Something about your age versus how much you can eat in a meal. Keep in mind that these are made-up numbers. So if we were to graph this, we would get a linear graph just like this. It's linear, so we can find the equation. We start the same way by identifying both our x and our y values, or the variables. The x is the independent variable, or the age. The y is our dependent variable, or how much we eat. We'll abbreviate it by just calling it eat, which stands for how much you can eat. M is the slope, which once again is the rise divided by run. So let's look at 2 data points. Remember, we look at our best fit line and try to find the 2 data points that will fit best on that best fit line. In this case, I'm just going to take the last 2 data points. So our rise is from our 33 minus 23, since that is how much up it goes over the last two data points. So we have a rise of 10 ounces. To find the run, once again we look at the last two data points and we get 15 minus 10, so we went over by 5 years. Plugging those in, our rise divided by run, we get that 10 ounces divided by 5 years gives you 10 ounces per year. Or excuse me, 2 ounces per year. The line looks like it crosses the y-axis at about 3 ounces. If we look here, it's less than 5, about 3 ounces. So we'll say that the y-intercept is 3 ounces. Plugging all these into our equation, we get, instead of saying y equals mx plus b, we plug in all of our values. That y is eat, the m is 2 ounces per year, the x is age, and our b is 3 ounces. So the amount you eat is equal to 2 ounces per year times your age in years plus 3 ounces. And that's it. I hope you have an unbelievable rest of the day.